Welcome to the first lesson of Functional Programming with Bob the Developer. I've dedicated this lesson for explaining what it means to take a look at, solve problems using a functional perspective. Welcome to the very first lesson of Functional Programming with Bob the Developer. Today, let's talk about what it means to look at the world using a functional paradigm and what it means to become a functional programmer. Okay? Well, if you have searched on Google, you probably have encountered a definition like this. I call this definition pretty bad. Functional programming is a paradigm that allows you to write your code explicit. There's no state and mutability. And a lot of bloggers begin the definition using this method. And I know you guys, some of you guys are very confused by now. Well, I don't like this definition. What we're gonna do is we're gonna look into the past, what I like to do, and then introduce to why we use things. Okay? Well, first of all, let's begin with non-functional programming to appreciate functional programming. That's how I like to get started, right? So let's say you have a non-functional programming. Let's say in somewhere in view controller, your job is to loop through things, like loop through an array, an item, whatever that may be. So we have for example, we have a number array, and then you have a sum to track it, and then in order to sum things, you would do number in number, sum plus equals sum number. So you have the value of sum available in your hand like that, right? On the bottom right there, 6. Okay, so what if you want to use in the next view controller, you might have to use kind of similar functionality. What you probably have to do is you want to repeat yourself, okay? And as you can tell, this thing it gets to nowhere. You're repeating yourself, and this is horrendous. You never code this way, okay? You never, ever. So what we do is we just simply create a function, right? Okay? And save me from madness. Enter elements, int or t, if you want to be more a little cool, right? T or int, and then sum, you get the value of sum. And then in order to use the function, you simply use this, like that. So you've made a function, and that does work. The only thing you have to know as a user is to enter a couple of words, a couple of arrays into it, a couple of elements into it, okay? Well, you've already tasted functional programming. Here's my definition. My definition is functional programming is nothing more than using functions to derive result. And as it states, functional programming, you're using functions to program. So, yeah, that's it. That's what it means to become a functional programmer, using functions to use to code to get what you want. So functional programming is can be found using Excel's program. For example, let's say you have a spreadsheet here. Let's say a value from 1 to whatever, and then what you do is you use sum here, and then you simply drag it, and you get the value. Boom. You get the value of 55, okay? You've used a functional paradigm right now. What's happening is this spreadsheet provides a bunch of functions, okay? Just like what we've done here, provide save me from madness. This is default function provided by me, but in this case, this is a function probably written in JavaScript. I don't know, probably. If you're using Excel, probably written in C#. But this is a spreadsheet, so probably JavaScript. And then you simply use the function. So this spreadsheet provides a bunch of functions that financial people can use, and they don't really need to know what's inside a function. As long as you get the job done and it's fast, it's all good. So functional programming is nothing more than using functions to get the result what you want. And if you are working if you're analyzing financial data, for example, you don't want to know what the function looks like, what the function exactly looks like. You don't need to know, as long as it's fast and quick. So spreadsheet is an amazing place that functional paradigm is used, okay? That's it. That's what functional programming is. Nothing more than using functions. So, but also it's important to understand the characteristics of functional programming. Functional programmings are also known as we also call functional programming as declarative. What does it mean by declarative? Well, you simply declare or simply use that function. Or in other words, the user does not care about the process. For example, when you use the save me for madness, if somebody else is using this function, they don't care about how the elements you don't care about how the element looks like and how the function looks like. For example, my dad, who works in the he works with a lot of spreadsheet in Excel. He doesn't care how the sum function looks like. He doesn't care as long as get the job done. And if developer, the optimization, the speed is important, but most of the time you don't care. You just expect that things are optimized. So when you're working with this kind of functions, sum, average, these are just simple functions that provided by the Google engineers. We simply use them. So we don't care about the process. We don't care. As long as the function, we just enter the parameters and boom, right there. So we call it declare. We declare it to work. We just simply declare the function, use it, okay? So for example, this is also a great analogy. So how do you get to the Mountain Everest, okay? There are two ways to do it, okay? This is the Mountain Everest, right? Pretty tall, right? It's pretty tall. There are two places. Like this guy, you can climb from the bottom to top, okay? It probably take a while. Or you can also fly in the air and then just jump off from the airplane, okay? When you're using declarative programming, you don't care how the process is like. As long as you get to the bottom, the point B, okay? It doesn't matter the process. So when you're using some function, or sort function, you don't care how the sort function looks like. There are many ways to sort things out. There are many ways to sum things out. You can sum it by 10 plus 1, 9 plus 2, 8 times 4, 7 times 4, 6 times 1. They all at least 11 and times by 5 and you get the final result, right? That's one way to do that. Or you can do times, add like that. There are many ways to get the sum function, some value, right? But you don't care about the process. So declarative programming is not about, you don't care about the process, okay? But when it comes, the opposite is we call this imperative. In other words, non-functional. It tells you how you got the answer from A to B. For example, if you take a look at this way, you exactly know what you did to get the value of new sum, right? What you did was you created this variable, an array, constant, and you added to the new sum variable, right? You exactly know what happens. So if it explains how the process looks like, we call it imperative, okay? So for example, what we've done above is for and loop above is right there is imperative, okay? And by itself is not bad, but when it comes to when you want to make things more modular, you don't really care about how the process is like, as long as it's fast and quick, okay? As long as when you have some function, or as long as quick and fast, you don't care about the process, okay? So what are the benefits of functional programming? What are the benefits of it, okay? And it's not just about using just a bunch of functions. You got to understand why we use functional programming. Well, you already stated the fact that we don't have to repeat ourselves, but there are a couple things to consider. Okay, the first one is a functional paradigm ensures no mutability or no change in state when used, or in other words, there's no explicit state management. Well, right, it's a big sentence. Well, let's talk about it. When you're using functions, okay, this is it. You don't care about the internal process. As long as you enter this value, the internal process should work 100%, right? It should always work. But when it comes to non-functional programming, like this way, what's happening is the sum value, it keeps changes. All right, as we go through this for and loop, we call the state of sum keep changes as you run this function. And when it comes to functional programming, you don't care about you don't track the state. The track is already state internally by the function save me from madness. All right, it's internally done, so you don't have to explicitly manage the state. All right, it's already internally. It's gonna work if you use functional programming, so you don't have to care about it. Okay, so here comes. So also the second part is modularity, which is one of my favorite words of all time, is the fact that you can carry it like a variable. For example, you can, when you're using Excel programming or spreadsheet, you can simply carry around, define a couple functions if you need to use it. There are a lot of functions available. They're very portable. It doesn't matter whether it's sheet 29, sheet 35, 1025, doesn't matter. The functions are very portable, modular. Okay. And by the way, also the fact that functional programming ensures no immutability, so you don't have to test things out. So if you're into test-driven development, when you're using non-functional programming, you have to test whether new sum is changing, whether it's being added, the value has been added. You possibly have to do it because the value constantly changes. But if you're using functional programming, as long as you test the fact that it works, it works. Okay, so it becomes much more safer when you're using functional programming because you don't have to do. Because sometimes if you're using non-functional programming, you might mistakenly press something different, put different number. If you're not using Swift, you're different value here. Of course, if you're using Swift, it kind of tells you that, hey, you're gonna put the right number. But if you're working with something like JavaScript, C++, you don't exactly know until you compile it. So it's not going to give you that warning sign on the left side. So functional programming ensure ensure that things like that don't happen. You don't want to have a lot of problem by not typing, doing something like this. Okay, for functional programming, all good. It doesn't, as long as you test the functional programming, this function, it's all good. Okay, and lastly, and of course, it comes along with fewer lines of code. All right, so let's compare. So we had 1, 2, 3, 4, 5, 4 lines, 1 line, and of course the function definition should be stored somewhere else. But when you're using it, just 1 line of code. And lastly, and the most importantly, which is a conventional communication that functional programming provides. What I mean by that is, when you're using non-functional programming, you're working with a bunch of developers. They have to read what it means. So when you're using var here, some developer may use it as the sum of the sum product, or when it comes to numbers, they could say array, and then some might call it elements instead of calling number. So when you're working with different developers, you start to have different communication language, and if you have a lot of languages, talking about different vocabulary, it becomes much harder to read because somebody has to read the entire function, had to retard imperative code to understand what the heck's going on. But when it comes to functional programming, all you have to do is define the function, or use a function. If you have any problem, go to the function and use it throughout. So nobody has to read this thing called new number, this thing called numbers. Okay, nobody has to read that. If you are repeating yourself with a bunch of new numbers, new number, element, it gets really complicated. So that's why you simply use functions to do that. So again, functional programming provides conventional communication throughout the entire app, fewer lines of code, modularity, which is my favorite part, and no mutability. You're less likely to, sometimes I call it freak up, or less likely to face problems. Let's put it that way. That's a nicer way of saying it. That's why we use functional programming. Okay, so this lesson was all about introduction, why we use functional programming, and the definition itself is very simple. Nothing more than, this was pretty bad. Again, nothing more than using functions to get the value you want. Okay, so in the next lesson, you will learn the power of functional programming, real life examples, and you will change your perspective on how you code. By the way, before you move on to the next lesson, make sure you're 100% confident with closures, okay? When it comes to functional, that closures are functions. Instead of using normal global function, we're going to use closures throughout the entire lessons. And if you're not comfortable with the closure, you're not ready to go. So go back to chapter 3, or chapter 4, master Clojure before you move on to it. If not, you will suffer more than you need to. Get the fundamentals of Clojures. See you in the next lesson. You should get pumped because you will never code the same way as you did before. With Bob the Developer, let's begin. I trust you guys. See you guys. Now, I've demystified the concept of functional programming in Swift. Based on my terminology for you, is nothing more than using functions to drive results. In the Swift Foundation library, it already provides dozens of useful functions for us developers to use. As a developer, you've got to know what's going on underneath of each function. In the remainder of this chapter, you will learn how those functions are created, and also you'll be able to create your own custom function depending on your need. The lessons will get tougher. So please make sure you're 100% comfortable with closures and generics. Let's see you in the next lesson.